my dear PU2 aspirants, so yes, your midterm exams are ahead and there is one very easy section where you can easily score marks, and that is the numerical sections. If you have just revised the formulas properly, you have understood the question properly, nobody can stop you from getting full marks in section E, that is 9 out of 9. So in this video, we are going to discuss top 20 numericals from the chapter Electrochemistry and Solutions, and remember, these all questions have been picked up from the PU2 question board bank, previous year questions, model question papers and sample papers. So let's get started with the first question, and the first chapter we are going to deal with the solution chapter. So basically for the first question, I'll just, overall there are 3 steps to solve a numerical question. So what is your step 1? So let me explain that, and I will not be following all the steps in all the questions because it will take the video very long. I'll just tell you how to solve the question, what should be the data, but yes, I'll tell you something first. Let me just introduce how to solve the question. So step 1 is to write the given values. Okay, the step 1 is to write the given values. But remember, when you write these given values, do not forget to explain the terms. Okay. Means, for example, if you want to write weight of the solute or mass of the solute, you are considering it as WB. So just write down WB is equal to weight of the solute is equal to this much gram. So you have to write the term, then the symbol that you are using to denote that term, and then the values. This is step 1. Now step 2 is to write the formula. Okay. Step 3 is to calculate to substitute the values and then calculate. Okay, we need to substitute, calculate, and then write the final answer. Write the final answer with units. Okay, so these are the steps to be followed while you write any numerical question. So I will be showing the first question, this one I'll be showing you how to write it, and others we will just solve it quickly. Okay, so let's go to the first question here. Calculate the molality and mole fraction of the solute containing 3 gram of urea, molar mass 60 gram per mole per 250 gram of water. Okay, so let us just write down all the values that is given. So what I'll write, weight or mass you can write. Okay, weight or mass, weight of the solute. Okay, and this is WB, which is equal to 3 grams. Okay, next is molar mass of the solute. Molar mass of solute, which is MB, and that is equal to 60 gram per mole. Now coming to weight of solvent. Weight of solvent, okay, that is WA is equal to 250 gram of water. Okay, 250 gram. So now let us substitute the formula. Okay, we want to calculate what? Molality. So you can write down molality, okay, which is denoted as M, is equal to WB by MB into 1000 by WA. Okay, now see, since I have already defined what is WB, MB, what is WA, now I can directly use it in the formula. So now if I just substitute it, what I will get? So that is equal to, WB is equal to 3, MB is 60 into 1000 and WA is 250. Okay, so I will get 0.2 something. We'll see the calculation. I have already calculated, but this is how you have to solve it. Now after moving to the next question, I want to calculate something else, that is, I want to write down here moles of solute. Okay, moles of solute, which is equal to NB, which is equal to WB by MB. Okay, next, one thing else I want to write, moles of solvent, okay, which is equal to Na that is equal to WA by MA. Okay. Now molar mass of solvent. Molar mass of solvent, that is MA here. Since it is water, we can write down here 18 gram per mole. Okay. So now I have denoted these two. I'll tell you why. So let's go to the second part of the question. So I'll recommend you that when you are writing the given values, just leave some space there so that as of question comes, you can still add on any information is required there. Okay. So now let us solve the question for mole fraction of solute. Okay. Mole fraction of solute, that is equal to, denoted as XB, is equal to NB by NA plus NB. Right. Now how can I expand this one? That is equal to WB by MB divided by WB by MB, okay, plus WA by MA. Okay. Now after this is there, we can just substitute the values here. So what I will substitute, WB is how much? 3 by 60, okay, divided by 3 by 60 plus 250 by 18. Okay. Now once you calculate this, you will get the answer for both the thing. So this one, as I told you, 0.2, and this one you will get 0.0039. Clear? I hope this is clear. Okay. Moving to the next question, question number 2. Yes, if 22 gram of benzene is dissolved in 122 gram of carbon tetrachloride, determine the mass percentage of carbon tetrachloride and benzene. Okay. Here you don't have to like, you can just write down answer and the given values. So what are my given values here? Given values I can write. First is, I'm just writing here weight of benzene, okay, which is equal to 22 grams, and weight of CCl4. Now please remember, you have to explain this term, mass of benzene, you have to explain, or weight of benzene, then you have to write this symbol. Do not directly write W benzene. Okay, you have to make understand the examiner that what is that this term refers to. Okay, and this one is 122 grams. Now if I want to calculate here, what I'll calculate, the mass percentage of benzene, that is equal to weight of benzene divided by weight of benzene plus weight of CCl4. Now that is equal to 22 divided by 22 plus 122. Okay, that is equal to 22 by 144. Now similarly, you can also calculate the mass percentage of CCl4. Okay, now here I want weight of CCl4 whole divided by CCl4 plus benzene. Okay, now this is equal to 122 divided by 122 plus 22, which is equal to 122 by 144. Now if I solve these two questions, then I will get here mass percentage of benzene is 15.28% and mass percentage of chloroform is 84.72%. Okay. Now moving forward to question number 3 here, the mole fraction of helium in a saturated solution at 20 degrees Celsius is 1.2 into 10 to the power of -6. Find the pressure of helium above the solution given Henry's constant of at 20 degrees Celsius is 144.97 kilobar. This is also a very direct question. First question that is given to me is mole fraction of helium. So you can write down the given values. What are the given values here? Mole fraction of helium. How do I denote it? X of He. That is equal to 1.2 into 10 to the power of -6. Next, the question is given to me is Henry's constant. So Henry's constant, how do I denote it? I denote it as KH. Now this one is equal to 144.97 kilobar is there. You can just convert it into bar. Next I will write, the question is asking you to find the pressure of the helium gas. So P of the gas is equal to, I can write down as pressure of helium gas. Okay, this is the given value. Now I will write what? The formula. Formula will be P of the gas is equal to KH into mole fraction of the gas. Now P of the gas I have to calculate. KH I can directly substitute 144.97 into 10 to the power of 3, okay, divided by mole fraction 1.2 into 10 to the power of minus 6. Now if I solve this, you can get the final value which is equal to, if I solve this, you will get 0.173. Okay, just multiply this one, you will get 0.173 bar. Okay, why bar? Because this unit is bar and this is unitless. So final answer will get 0.173 bar. Now moving to the next question. The vapor pressure of pure liquid A is 40 mm Sg at 310 Kelvin. The vapor pressure of this liquid in the solution with liquid B is 32. Okay, here it is missing 32 mm of Sg. Calculate the mole fraction of A in the solution if the mixture obeys Raoult's law. So let us first again write down all the given values here. Okay, so you need to describe properly vapor pressure of pure liquid A. Okay, so I am just writing here vapor pressure of pure liquid A, which is denoted as P naught A, is how much? 40 mm Sg. Okay, the vapor pressure of this solution with liquid B. So I can write vapor pressure of liquid A in solution, that is PA is equal to 32 mm Hg. So that is all there. Now we can write down, we have to calculate the mole fraction of A. So let denote XA is equal to mole fraction of A, mole fraction of A, and XB is equal to mole fraction of B. This is done. Next we will write the formulas here. So formula I can write down P naught A minus PA by P naught A, okay, is equal to XB. Okay, so if I substitute the values, what is P naught A? 40 minus 32 divided by 40, okay, is equal to XB. So 8 by 40 or 1 by 5 or 0.2. So I will have XB is equal to 0.2. Clear? So now what is XA here? XA is equal to mole fraction of solvent, okay, which is equal to 1 minus 0.2, that is equal to 0.8. Okay, so now if I solve this, you will get XA is equal to 0.8. Clear? Moving to the next question, calculate the mass of a non-volatile solute which should be dissolved in 114 gram of octane to reduce its vapor pressure to 80%. Okay, so again let's write down the given values first. Okay, so what I have, the calculate the mass of a non-volatile solute whose molar mass. So let us write down WB is equal to the weight of solute. Okay, MB is equal to molar mass of solute, molar mass of solute, which is equal to how much? 40 gram per mole. Done? Yes, ma'am, done. Next, what mass, calculate the mass of non-volatile solute to be added, which should be dissolved in 114 gram of octane to reduce its vapor pressure to 80%. Okay, so let us write down. So you see here, octane is the solvent, right? In the octane you are dissolving this non-volatile solute so that the octane vapor pressure should decrease to 80%. So if it is, whenever it is percentage, you can assume that the initial pressure was 100%. So first let us write down what is WA, weight of solvent, or you can write down weight of solvent, which is octane here, is equal to how much? 114 grams. Okay, and then I have MB, octane molar mass also we need, so let us define that term also. MA, okay, MA is molar mass of solvent octane. This is 114 gram per mole, right? This is very clear to all of you. Let's now move to the pressure. P naught. What is P naught here? Pure pressure of octane, pure pressure of octane, which is equal to 100%, and then P will be the reduced pressure of octane, which is 80%. Okay, clear? Now here I also want to denote some more terms. NB is equal to number of moles of B, or number of moles of solute, which is equal to WB by MB. Similarly, NA is equal to number of moles of my solvent, which is octane here, so WA by MA. Okay. Now after denoting or giving all these values, then only go for formula here. So what is my formula? Delta P by P naught, which is equal to P naught minus P by P naught, is equal to XB is equal to NB by NA, okay, is equal to WB by MB divided by WB by MB plus WA by MA. Okay, now here we have 100 minus 80 by 100 is equal to WB by MB. So what was WB here? For WB I have to calculate, right? Okay, so here you see in this type of questions, okay, in the Raoult's law question, and XB is equal to NB by NA just, okay, we don't, we ignore the NB in the denominator, so this one is not required. Why we ignore? I'll tell you that, just a minute. So what I'll get? WB by MB divided by WA by MA. Now here we assume that NA is hugely large than NB, so that we can neglect the term NB. Okay, this is done to make the calculations easier. Okay, so now 100 minus 80 by 100, WB I have to calculate. MB is how much? MB is 40, right? WA is 114 gram and MB is also 114 gram. So now if I just need to solve this, 20 by 100 into 40 is equal to WB. Okay, so that is 8 grams I need. So let me just check. Yeah, we'll get 8 grams here. Clear? Clear everyone? Okay. Next question. The vapor pressure of 5% aqueous solution of a non-volatile organic substance at 373 Kelvin is 745 mm. Calculate the molar mass of the solute. Now please understand the question. So there is an 5% aqueous solution. 5% aqueous solution means in 100 gram of solution, 95 gram is water and 5 gram is that solute. Okay. of a non-volatile organic substance at 373 Kelvin is 745. So if you know the water vapor pressure is 760 mm of Sg. Now due to the addition of this 5% solution, an organic solute, the pressure has decreased to 745. So now you have to calculate the molar mass of this solute that is being added. So again, the question is very similar to the vapor pressure question, but here certain things you need to know, some assumptions that is required here. From now onwards, I'll just directly write down the values and I'll solve the questions. I won't be explaining the terms. Okay. So first of all, 5% aqueous solution means you have to understand that total mass of the solute is, total mass of the solution is 100 gram. In that, what is the mass of the solute? Mass of the solute is 5 grams. Okay. Then what is the mass of the solvent? Since it is a aqueous solution, so mass of the solution is 95 grams. Okay. Then what is the molar mass of solvent? We know it is water, so it is 18 grams per mole. Okay. After that, we need that the pressure of water, okay, pure pressure of water is always 760 mm of Sg. This is what you have to assume. Okay, you have to assume since it is not given in the question. Next, I have P here, that is pressure of water is 745 mm Hg. Okay, that is there. Next, calculate the molar mass of the solute. Yeah, so molar mass of the solute I can start from here. So my formula is what? P naught minus P by P naught is equal to NB by NA. XB is there, right? XB is equal to NB by NA. Now I have P naught value, which is 760 minus 745 divided by 760 is equal to NB is 5 by MB into 95 by 18. Okay, so now if I solve this, I'll get 15 by 760 something is equal to 18 by 19 MB. Okay, now here if you solve, MB will be equal to 18 by 19 into 760 by 15. Okay, now I can solve this one. 3 5s are 15, 3 6s are 18, then 5 1s are 5 2s are 10, 26 will get 19, 152 into 6 by 19. So if I solve this, I'll get the mass here. Okay, and I think this one you will not get. Let me just calculate. 6 2s are 12, 6 2s are 12, 6 5s are 30, plus 1 31, 912. Yeah, 912 divided by 19. So let us just divide this one. So 19 5s is 95, so 19 4s is, so I can take 4, 9s are 36, 376 here, 11 minus 6 is my 5, 8 minus 7 1 and 52, 8 can I try, 8 9s are 72, yeah, 48. So this one will be 48 grams per mole. Okay, do not forget to write the units. Moving to the next question, the vapor pressure of water is 92 mm of Sg at 323 Kelvin. 18.1 gram of urea are dissolved in 100 gram of water. The vapor pressure is reduced to 5 mm. Calculate the molar mass of the solute. This is again molar mass of urea. So again very similar question. The vapor pressure of water is 92. So that is pure water. So P naught is 92. Okay, again I am telling you I am not defining the terms, but how I did for first 3-4 questions, like that you have to define the terms. So P naught is there, then what is the mass of urea? 18.1 grams. Okay, and we know that okay, 100 gram of water, so WA is also given to me, which is 100 grams of water. The vapor pressure is reduced by 5 mm, so delta P is equal to 5. Okay, reduced by 5 mm means the difference is 5 mm. Next, I also know that since it is dissolved in water, so MA is 18 grams per mole. Right, now I can calculate here delta P by P naught is equal to XB, or can be written as WB by MB whole divided by WA by MA. Okay, now if I solve this, delta P is 5, P naught is 92, is equal to WB is 18.1, okay, by MB into 100 by 18. Okay, now you can solve this and find the value of MB, which is 56.7 gram per mole. Okay, moving to the 8th question. Calculate the osmotic pressure in pascals exerted by a solution prepared by dissolving 1 gram of polymer. So here 1 gram of polymer, WB, I can write down 1 gram, okay, of molar mass, that is MB, which is 1,85,000 gram per mole. Okay, next we have 450 ml of water, so I can write volume is equal to 450 ml of water. Temperature, this is actually 37 degrees Celsius. Okay, temperature is 37 degrees Celsius, or you can just add here, you will get to 310 Kelvin, right? That's all I think we have. 1 gram of polymer. Yeah, next let us write what is C here. C is concentration, just mention that, concentration in molarity, or you can simply write down molarity also. Okay, and next is R is gas constant, whose value is 0.0831 liter Pascal. One second. Yeah, into 10 to the power of 5 liter Pascal mole inverse Kelvin inverse. Now why I am getting this 10 to the power of 5? Because it is in Pascal. 1 atm is 10 to the power of 5 Pascals. So that is why we got. Now I can write down, and what is my pi? Pi is osmotic pressure. Okay. Now I can substitute the values and first write down the formula. So I can write here pi is equal to C into R into T. Now what is C here? Given mass by molar mass, right? I have already defined all of them, into 1000 by volume into R into T. Now substitute quickly. 1 by 185,000 into 1000 by volume is 450 into 0.083 1 into 10 to the power of 5 into 310. Now if I calculate this, you will get the osmotic pressure, which is 30.9 Pascal. Now question number 9 here, calculate the concentration of that solution of sugar which has an osmotic pressure of 2.46 atmosphere at 300 Kelvin. Okay, so here also we have been given with the osmotic pressure value, which is 2.46 atm. Then we have temperature of 300 Kelvin. Okay, now we have to calculate pi is equal to C into R into T. So first of all, C will be equal to what? Pi by R into T. Pi value is 2.46 atm. Okay, R value is 0.0831 liter atm mole inverse Kelvin inverse, and temperature is 300 Kelvin. Okay, Kelvin inverse is cancelled, atm is cancelled. Now I have mole liter inverse I will get. So just if you solve this, see, if you solve this, you are getting the answer in terms of mole liter inverse. Okay, but concentration is asked, right? You can keep it. You can also find out the answer in terms of grams per liter. So if I just want to convert, this is which one? Sugar, right? Sugar mass is 342 grams per mole. So I want to convert it into grams per liter. So 342 grams liter inverse. So what I will get here? Grams per mole. 342 grams per mole. Okay, so mole inverse will get cancelled. I'll get grams per liter. You will get 34.42 grams per liter. Okay, next question, calculate the molar elevation constant of water It is given that 0.1 molar aqueous solution of a substance boiled at 100.052 degree Celsius. Again, this is also very direct question, 0.1 molar aqueous solution. So molality is given to me 0.1 molar, right? And then boiled at 100. So we know TB, the boiling point of water is 100 degrees Celsius, T naught B. Then what is TB here? 100.052 degree Celsius. So now we have here delta TB is equal to T naught B minus TB is equal to KB into M. Now T naught B minus TB, not T naught B, TB minus T naught B, because we have the boiling point of the solution is more than the original boiling point, right? So TB will be 100.052 minus 100 is equal to KB into 0.1. After solving this, I'll get the value of KB, which is equal to 0.052 degree Celsius. Now coming to question number 11 here. The boiling point of benzene is 353.23 Kelvin when 1.8 gram of a non-volatile solute was dissolved in 90 gram of benzene. The boiling point is raised to 354.11 Kelvin. Calculate the molar mass of the solute. Kb for benzene is 2.53 gram Kelvin kilogram mole inverse. So just 1 minute, I'll just check one question. Okay, fine. Let's move to this question. Yes. So the boiling point of benzene, so I can write T naught B is 353.23 Kelvin. Next, when 1.8 gram of non-volatile solute. So what is WB here? 1.8 grams. Dissolved in 90 gram of benzene. Okay. The boiling point is raised to okay. Calculate the molar mass of the solute. Okay. Kelvin, kg, mole inverse. So now if I just want to calculate the molar mass of the solute, so you have to use the delta TB formula. Okay. So delta TB is equal to TB minus T naught B is equal to KB into given mass by molar mass into 1000 by mass of the solvent. Okay. TB is equal to 354.11 minus 353.23 okay, is equal to KB is 2.53, WB is 1.8, okay, and molar mass here is, calculate the molar mass of the solute. So that is equal to, we have to calculate, right, MB into 1000 by WA is 90. Now you have to solve this and calculate the value of MB, which is 58 gram per mole. Now moving to the next question, a solution containing 34.2 gram of cane sugar dissolved in 500 ml of water froze at minus 0.374 degrees Celsius. Calculate the freezing point depression constant of water. Now let us see here, WB is how much? 34.2, okay. Then we know this is sucrose, so molar mass will be 342 grams per mole, okay, dissolved in 500 centimeter cube. So you can, for water, since the density is 1 gram per ml, you can write down this as WA is also 500 grams, okay. Next, freezing point TF is minus 0.374 degree Celsius. What is T naught F here? 0 degree Celsius, okay. And I have to find out here KF value, okay. So now delta TF is equal to KF into M. Now delta TF is what? Tf minus T naught F, or T naught, in this case it will be T naught F minus Tf. So 0 minus 0.374 is equal to Kf into M. 34.2 divided by 342 into 1000 by 500. Okay, now if you solve this and find the value of Kf, it is 1.87 Kelvin mole inverse. Okay, molar inverse. Now 13th question, the solution of urea in water has a boiling point of this one. Calculate the freezing point of the same solution. Molar constants of water Kf and Kb are 1.86 degrees Celsius and 0.512 degree Celsius respectively. Okay, so let's see this question now. Solution of urea in water has a boiling point. So you have here Tb is equal to 100.128 degrees Celsius and T naught B is equal to 100 degree Celsius. Then you have here Tf is equal to 0 degree Celsius, T naught F, sorry, I have to find this one. T naught F is 0 degree Celsius, Tf I have to find out. Apart from that, I have Kf value which is equal to 1.86 degrees Celsius and Kb value, okay, which is 0.512 degrees Celsius. Okay, Kf value and Kb value. Now if I want to calculate here, delta Tf is equal to Kf into M and delta Tb is equal to Kb into M. Now what is delta Tf? Tf value is delta Tf is 0 minus Tf and delta Tb is this one. If you have to subtract Tb minus T naught B, I will get 0.128. What is Kf value? 1.86 and we have 0.512. Okay. Now if I solve this, I will get the value of Tf which is minus 0.465 degree Celsius. Okay. So now we will move to the next question, next chapter, that is electrochemistry, and we'll solve some numericals from this particular chapter. Okay. So coming to question number 1, the resistance of 0.01 and solution of an electrolyte is 100 ohm. So for this first question also I want to just write down the values. Resistance is how much? 100 ohm. Okay, so but you need to, how you need to write? Okay, first question I want to solve in detail so that you can know how to write down. So first thing you have to write is resistance denoted by R is equal to 100 ohm. Next we have to calculate conductance. Okay, so conductance, how will you denote? Conductance is denoted as G. That you have to calculate. Then you have been given with conductivity. Conductivity. So this one you can, this all three things you can write down while you are solving the question only. You don't need to write now. Cell constant is given. Okay. Cell constant is given to you. Cell constant is denoted as G star. Okay, which is equal to 1 centimeter. Okay. So let's now solve the question. The first one is conductance. Conductance, which is G is equal to 1 by R, and if I solve it, 1 by 100, you will get 10 to the power of minus 2. Very simple. Moving to the next one, you have conductivity. Conductivity or kappa. Now you know this formula, R is equal to rho into L by A. Now this L by A is cell constant, right? So since I have defined cell constant, I will write in this place I will write in this place G star. Okay, that is L by A. Now so I can just write down kappa is equal to 1 by R into G star, right? Kappa is equal to yeah, that's correct. So 1 by R is 100, G star is 1, I'll get 10 to the power of minus 2. Okay, so conductance here is ohm inverse. Okay, ohm inverse. Next here is conductivity, which is equal to S centimeter inverse. Now next we have resistivity. Okay, the third one is resistivity. Resistivity, which is rho, and rho is just the inverse of this one, so it is equal to 100 ohm centimeter. Okay, so now you can just find out the answers here, that is there. Okay, next question number 2 here. For the standard cell, copper to copper 2 plus gives silver plus to silver, E naught value of copper and silver is given. Identify the cathode and anode as the current is drawn from the cell. Okay, identify the cathode and anode. So you know cathode is where reduction takes place, anode is where oxidation takes place. So in this particular cell, copper is undergoing oxidation, right? So if I see the first one, cathode will be which one? Silver is undergoing, so it is silver, and anode is my copper, right? Write the reaction taking place at the electrodes. So you have to write the reaction for cathode. So at cathode what is happening? Silver is undergoing reduction. Okay, and then we have anode here. Anode reaction is copper will give me copper 2 plus 2 electrons. Next, third one we have is standard cell potential. Standard cell potential is what? Cathode minus anode. So E naught of the cell is equal to cathode minus anode. Cathode is 0.80 minus anode, which is 0.34. Okay, 0.46 volt. Next, coming to question number 3, calculate the potential of hydrogen electrode in contact with a solution whose pH value is 10. Okay, so now if you have pH is equal to 10, right, that means pH is equal to minus log of H plus, which is equal to 10. So I can write down here H plus is equal to 10 to the power of minus 10. Okay, now you have to calculate the cell potential. E of the cell is equal to E naught of the cell minus 0.0591 by N log of H plus. Okay, so you can substitute, this is 0.0591 by 1 log of 10 to the power of minus 10. Okay, now if I solve this, I'll get 1 second. Okay, I made a mistake here. The equation is like this, right? So what it will be? 1 by H plus. I'll just write down here 1 by H plus. So I'll get 1 by 10 to the power of minus 10. This goes up, it will become 10 to the power of 10. So it comes here, so I'll get minus 0.591. Okay. Next, question number 4, calculate the EMF of the cell in which the following reaction is taking place, given that the E naught of the cell is this much. Very simple question, Nernst equation, again we have to solve. E of the cell is equal to E naught of the cell minus 0.0591 by N. By N here you should know, because number, see, N is how much? 2, because N nickel is undergoing 2 plus, 0 to 2 plus, 2 electrons are involved, and silver from Ag plus to Ag, 1 electron is involved, but 2 silver is there, so N value is 2 here. Log of nickel 2 plus by Ag plus square. So we have E naught value is 1.05 minus 0.0591 divided by N value is 2 log of nickel 2 plus is 16 into 10 to the power of minus 2. Okay, you can see nickel concentration here. Silver concentration is 2 into 10 to the power of minus 3 square. Okay, so I'll get here 1.05 minus 0.03 log of, okay, So we'll have 8. So if I just solve, it will become 4 into 10 to the power of 4. Okay, so if you solve this one, so log 4 is how much? 0.602, and this is 4. Log 10 to the power of 4 is 4. So I'll get 4.602 here. 1.05 minus 0.03 into 4.602. Now if I solve this, you will get the value of 0.91 volt here. Fifth question, the cell in which the following reactions takes place has E0 cell is equal to 0.236 volt. Calculate the standard Gibbs energy change and the equilibrium constant for the cell reaction. Okay, so now if you see here, delta G is equal to minus NF E0 of the cell. So minus, we have Fe plus 3 to Fe plus 2, the 1 electron is involved. So 2 Fe will have 2 electrons. So this is 2 into 96500 into E0 of the cell is 0.236 volt. Okay, if you solve this, you will get the value of delta G. Now we have to solve the value for equilibrium constant, right? So we know that from Nernst equation, E of the cell is equal to E0 of the cell minus 0.0591 by N log of product concentration by reactant concentration. We know this equation, right? Now at equilibrium, what happens? E of the cell becomes 0. So if this is 0, what will be my equation now? E0 of the cell is equal to plus 0.0591 by N log of. Now at equilibrium, this value becomes equilibrium constant and can be written as log K. So now I can substitute here. What will be my log K? So if I continue from here, log K value will be E0 of the cell, which is 0.236, okay, into N value, as I have discussed here, N value is 2, divided by 0.0591. Okay, so if I just solve this one, 2 6 are 12, 2 3 are 6 plus 1 7, 2 2 are 4, 0.472 by 0.591. Okay, so now if I solve this, 0.472 divided by 0.591, you will get 8. So this value will be approximately 8. So K will be 10 to the power of 8. Okay, so if you see the question, this one will be minus 45.5 and this one will be 10 to the power of 8. Okay. Question number 6 here, the molar conductivity of 0.025 mole liter inverse methanoic acid is 46.1 s centimeter square mole inverse. So let's just write down the value. Concentration is 0.025 mole liter inverse and the molar conductivity lambda m is 46.1 s centimeter square mole inverse. Okay, calculates its degree of dissociation and dissociation constant. Degree of dissociation is equal to lambda m by lambda naught m. Okay, now let's just find out this value of lambda naught m here. Lambda naught m is how much? Molar conductivity of H plus and molar conductivity of HCOO minus. If I add these two values, so what is the molar conductivity of H plus? 349.6 plus 54.6 into S centimeter square mole inverse. Okay, so now if I just add this one, 6 plus 6 12, I'll get 9 plus 1 10 plus 4 14, I'll get this one I'll get 404.2 S centimeter square mole inverse. Okay, now if I want to find this value, this is 46.1 by 404.2. Okay, that will give me alpha value. Now how to calculate degree of dissociation we have understood. Now what is dissociation constant? This is C alpha square by 1 minus alpha. Now if you solve, I think you will get 0.114 here. Let me just check. Yeah, 0.114 you will get. So here you can substitute. C value is 0.025 into 0.114 whole square divided 1 minus 0.114. Okay, if you solve this, you will get the value of 3.67 into 10 to the power of minus 4. Nearly this value you will get. Moving to the next question, if a current of 0.5 ampere flows through a metallic wire for 2 hours, then how many electrons flow through the wire? Okay, so first of all, we know that Q is equal to I into T, right? So what is current here? 0.5 ampere into 2 hours into 3600 seconds. Always remember, time has to be in seconds. Now if I just solve this, I'll get 3600 coulombs. Now you know that 96,500 coulomb is equal to, is the charge carried by 1 mole of electrons, or is the charge carried by 6.022 into 10 to the power of 23 electrons. Now 1 coulomb will be equal to how much? 6.022 into 10 to the power of 23 divided by 96500. Now for 3600 coulomb, how much I will get? 6.022 into 10 to the power of 23 divided by 96500 into 3600. Okay, now if I multiply this one, we will get the answer or the number of electrons. So that is 2.246 into 10 to the power of 22. Okay, you can solve it and you will get this value. Now moving to the 8th question, the resistance of a conductivity cell containing 0.001 m KCl solution at 298 Kelvin is 1500 ohm. So just let me write down, resistance is how much? 1500 ohm, concentration is, okay. What is the cell constant if the conductivity of 0.001 m KCl solution at 298 Kelvin is? Conductivity is conductivity is 0.146 into 10 to the power of minus 3 s centimeter inverse. Okay, so now we have to find the conductivity formula. We know conductivity is equal to 1 by R into L by A. Now this L by A is only cell constant, so it is kappa into R. So just we have to multiply the value, 0.146 into 10 to the power of minus 3 into R value is 1500. Now if I solve this, you will get 0.219 centimeter inverse. 9th question here, how much electricity in terms of Faraday is required to produce 20 gram of calcium from molten CaCl2? So I have Ca2 plus 2 electrons, we will have calcium here. Okay, so 20 gram of calcium is there. So if you have 40 gram of calcium we want to produce, I need 2 Faraday. You can see 40 gram 2 Faraday. So for 1 gram of calcium I will require 2 by 40 Faraday. Okay, and then for 20 gram of calcium we will have 1 Faraday, right? So 2 by 40 into 20, that is 1 Faraday. Next question number 2 here, for aluminium, okay, so for 27 gram of aluminium it is produced from 3 Faraday. For 1 gram it will be produced by 3 by 27 Faraday. Next we have, next what we had, for 40 gram of aluminium we will have 3 by 27 into 40. So now if I solve this, how much I will get? You will get around 4.44 Faraday. Okay. Next, moving to question number 10 here, a solution of nickel nitrate is electrolyzed between the platinum electrodes using a current of, so what is current here? 5 ampere, and time is 20 into 60 seconds. Now what mass of nickel is deposited? Okay, so mass of nickel deposited, how the nickel will get deposited? Nickel 2 plus will gain 2 electrons to get nickel or to form nickel, right? So here we have to use Faraday's first law, which says M is equal to Z into I into T. Now what is Z here? Molar mass divided by N into 96500 into I into T. Now molar mass of nickel is 58.6. Okay, molar mass of nickel is 58.6 and this is 2, this is 96500. Okay, then I have I current is equal to 5, this is 20, and then we have 20 minutes into 60 seconds. Okay, so if I just solve this, you will find the mass of nickel deposited, which is 1.825 grams. Clear? Now we will have, yes, so students, these were the top numericals from both the chapters, solutions and electrochemistry. So if you practice these numericals, your basics, your formulas will be cleared. Now you will not be getting the exact question, but similar questions only will be asked in the exam, so no need to fear. And if you just practice these 20-25 questions, section E is done for you. So thank you so much for watching, and if you have any doubt or any discrepancies in any answers, do let me know in the comment section. I'll definitely address to it. So thank you so much. All the best for your midterms, and do let me know how was your exam. If it is done, if it is not done, then just prepare well. Thank you once again.